on today?
Hey, Chris. So today we're working on this machine here. We're going to test the susceptibility of an asphalt mixture to rutting using the Hamburg Wheel Tracking machine.
What? I thought rutting wasn't a problem.
Well, it isn't right now, but it used to be a big problem. Through changes in mix design, binder grading, and tests like this, it's been reduced significantly over the years. Plus, these kinds of tests are being used with the balanced mix design process, and it helps designers pick the optimum binder content.
Cool, so tell me about this hamburger test.
No, it's the Hamburg Wheel Tracking Test. Actually, it was developed in Germany, and it's been used since the 1970s.
So it's almost as old as you?
Whatever. So actually, it uses the AASHTO 324 as the standard specification. So the samples can either be compacted pills, compacted slabs, or it can be field cores. So the important things to remember with these pills we're using today is that the height needs to be 62 millimeters and the air voids needs to be 7%, plus or minus a half.
7%? I thought we targeted 4.
Well, we do with mixed designs, but this is for performance testing here.
So we test this with the bulk specific gravity, right?
Exactly. Good job. So once we've verified that we have 7% air voids with this, we're going to cut off the edge here so that it will fit in this mold.
Oh, like 2 peas in a pod.
I guess. So I've already taken the time to lower the arms and zero the LTDs, and then I've raised them back up, loaded the samples in, and filled it with water.
Does it matter what the water temperature is?
It does. The standard says that the water needs to be 50 degrees Celsius, and we condition the samples for 45 minutes in that water, but never longer than 1 hour.
Okay.
So now that the conditioning time has passed, we've lowered the arms back down onto the samples.
That setup looks heavy.
So it is. So these smooth steel wheels have to apply 158 pounds, plus or minus 1, to the samples.
Can I push start?
You bet, but it's in the software. So let's take a look over there. So we need to put the project information into the computer. We're going to enter in our sample IDs, and then we're going to verify that we have the correct sample height of 62 millimeters input as well.
Okay, how about now?
Sounds good. Go ahead.
Look at that, back and forth, back and forth. How fast is that?
So the standard says that the machine needs to pass over the sample 52 times per minute, plus or minus 2 passes.
How long do we wait now?
Well, the standard also says that it needs to pass over the samples 20,000 times. So unless they fail early, it'll take about 6.5 hours. All right, so the test is complete and the water's been drained. Let's take a look at the results.
The sample doesn't seem all that rutted.
Well, it isn't. That's why it ran the full 20,000 cycles instead of stopping early. But if we look at the software, it looks like it rutted about 2.75 millimeters.
Well, that's a nice graph. Do we have calculations to do now?
Nope, no calculations with this, unless we're looking at stripping. But we'll talk about that another time. The thing about this test is, it takes so long to run that we can only run it about once a day. So let's go ahead and get everything set up here so we can run another one tomorrow.